Hey team, I just finished making this. I'm going to work through it. This counts as our test day tutoring. So let's go. Our 200 and 200 pi different numbers. How so? They're very different numbers. 200, guess what? Equals 200. 200 pi, however, if you get an approximation of 200 pi, it is approximately, double squiggly means approximately, 628.319. Are those the same thing? No, they're not. So please, I'm begging you on the test, if something says 200, it means 200. If something says 200 pi, it means 200 pi, which is approximately this number. Those are very different things. Let's see how it would look different in the next question. The volume of a cone is 500. Does it say 500 or 500 pi? It just says 500. So when we know the volume of a cone is 1/3 pi r squared h. We got the height, we've got the volume. So we plug those in, 500, not 500 pi, equals 1/3 pi r squared, r squared times h, which is 15. Then we have to solve for r. How do we do that? We got to undo all these things. So I'm going to start with 500, and I'm going to multiply by 3, gets rid of the 1/3. I'm going to divide by 15, gets rid of the times 15. I'm going to divide by pi, gets rid of the pi. And then r squared, I need to do the square root. So if you do that individually, you have 500 times 3 divided by 15. So this is the same as the square root of 100 over pi. That pi is a part of the number. It's got to be in there. So if I were to round the radius to the nearest tenth, I would have to do the square root of 100 divided by pi. Practice typing this in to the nearest tenth. That would be 5.6. If you had done 500 pi, the pi's would have just canceled out, and that would have been a very different question. So please pay attention. 500 is not the same as 500 pi. The test says what it means when it comes to that sort of thing. Namir, this guy, has a golden triangular prism. Look at that. That he wants melted down and turned into smaller golden square pyramids. Square pyramids. The triangular prism has an equilateral triangle base with perimeter 30 root 3. So let's start on the prism. The base, if the perimeter is 30 root 3, that means each side is 10 root 3, which means if we drop the height, this would be 5 root 3. And then the height would have to be 5 root 3 times root 3, which is 5 times 3. That would have to be 15. So the area of the base is 1/2 times 10 root 3 times 15. That would be 75 root 3. All right, so we have the area of the base. I don't even know if we need that, but I got it. The height of the prism is double the height of the triangular base. Okay. So if we were to draw the prism, if the prism would go back, if we draw the prism, that height would have to be double, double the height of the triangular base? Well, the height of the triangular base is 15, so that would make that 30. Okay, so the volume would have to be the area of the base, 75 root 3. Here, volume equals BH, the area of the base, 75 root 3. Times the height, which we just said is 30. So 75 times 30, that's 2250 root 3. All right. So I have the volume of the prism. He wants small pyramids. Remember, they were square pyramids, whose height is 3/10 the height of the prism. Oh, dear. Okay. So let's work on the pyramid. So if that height is 30, height would be 30 times 3/10. Well, that would be 30 divided by 10 is 3 times 3 is 9. Okay, so the height of the pyramid is going to be 9. because the height is 3/10 the height of the prism. Got it. Height is 9. He wants the square base to have a diagonal of 5 root 2. So let's draw the square base. If the diagonal is 5 root 2, 45, 45, 90 rules say that each side is 5, so the area of the base would have to be 25. How many pyramids can he make using the gold from his prism? Okay, well this volume would be 1/3 area of the base times the height. That would be 1/3 times the area of the base, 25, times the height we said was 9. So that would be 75. All right, so how many pyramids can he make? So he has this much total gold. Each pyramid uses this much. So what is that? 2250 root 3. 2250 root 3 divided by 75. And that is 51.962. So he can make 51 pyramids. He can't make the 52nd pyramid. Love it. A pyramid has a base that's a regular 20gon. We got a slant height, and the perimeter of the base is 200. Okay, let's work on just the base for a second. It's a regular 20gon. Every regular polygon, we draw a right triangle. We get the angle at the top. We're going to do 360 divided by, since there's 20 sides, we do 360 by 40, which is 9. This angle at the top is 9 degrees. If the perimeter is 200, how long is each side? 200 divided by 20 would be 10. Divided by 2 would be 5. So if the whole perimeter is 200, that means half of one side has to be 5, right? 20 sides would be 10 each. Half of one side would be 5. So this is our starting situation. I'm going to call this X. Actually, I'm not going to do that. You guys should know how to do this. So the trig, it'd be the tangent of 9 equals 5 over X. So this would be 5 divided by the tangent of 9. So the area of the base is going to be 1/2 times the apothem times the perimeter. So half of 200 is 100. 100 times 5 is 500 over tan 9. A few of you guys kept writing decimals on the quiz. Don't do that. Don't do that. It's harder to grade. It's harder to read. It's harder for you to do it. Just leave it like this, 500 over tan 9. You can round it at the end. Actually, on this one, we're leaving it exact, so we're not even going to do that. But stop writing decimals when you don't need to. Bad. All right. We want the volume of the pyramid. We need to know the height. So I know I've showed you guys this before. It's probably still pulled up. Let's go see. Pyramid, pyramid. Where'd my pyramid go? There's my pyramid. So copy that pyramid. Let's go, let's go. I've talked about this many, many, many times. So if you've got it down by now, awesome. I'm going to just kind of put this here. All right. Height is the thing we need. There's two situations. Slant height is vertex to middle. Well, what meets you at the middle? What is that called? That's the apothem. So if you have the slant height, there's a right triangle where the slant height's the hypotenuse. We don't need it for this problem, but the other possible situation is if I give you the lateral edge. Well, the lateral edge goes to the corner. What would connect the height to the corner? What goes to the corner? That's a radius. If it's a square base, these are easy numbers to get, not much work, but we don't have a square base, so we're going to have to do some work on that. But those are the triangles that we're going to be working with, my friends. So keep that in mind as we go forward. We need the height. We have the slant height. So we're going to draw a right triangle. The slant height is 8, and we need to connect the slant height to the height. How do we do that? Well, the slant height goes to the middle of the side. What meets us at the middle of the side? That's the apothem. and then this is the height. So the height equals the square root of 8 squared minus 5 over tangent 9 squared. That's the height. That's as simplified as we're going to get. I guess you could do 8 squared and 5 squared if you want, but that's good enough. We haven't really talked about that. But the volume of the pyramid is 1/3 area of the base times the height. So the volume will be 1/3 times 500 over tan 9 times the square root of 8 squared minus 5 over tan 9 squared. Not much we can clean up there. We could take the 1/3 and move it down here, but you can't do 1/3 of 500. So that's about as cleaned up as I'd expect you to get here, because it does say leave exact, so I'm just going to leave it like that. Woo! Find the volume, leave exact. All right, so let's see here. We got a rectangular prism. So let's work on the prism first. Prism is, if it's a rectangular prism, it's just length times width times height. Light work. That's going to be 6 times 6 times 10. That's 36 times 10. That is 360. Got the prism. Now this shape is a hemisphere, so what it looks like here is that it goes all the way across that direction, which would be a distance of 6. So the hemisphere, the radius would have to be 3. And we only have half the sphere. So half of a sphere would be 2/3 pi r cubed. What did I say? What is that? What is that? Pi r cubed. Come on, team. So many did pi r squared for sphere. And I just had to giggle every time, and then I got sad. Don't be that. You have a formula chart. Let's get it right. So the volume equals 2/3 pi times the radius cubed. So 3 cubed is 27, divided by 3 is 9, times 2 is 18. So that volume is 18 pi. So it says leave exact, so there's not much we can do here. Something else I saw you guys do is add these things together. That happened, several of you, or subtract them, or whatever you had to do. Guys, 360 doesn't have a pi on it. You can only add or subtract like terms. So please add or subtract like terms. So we can't add or subtract these, like we can't combine the 360 and the 18. So we just have to write it as 360 plus 18 pi. And we're done. That's all we can do. If it said round it, we type it in. Volume deals with how many dimensions. This is important, but it deals with 3. Now those 3 dimensions can look different on different shapes. For like a pentagonal pyramid, that's an apothem, a perimeter, and a height. Those are the 3 things you're multiplying for a pentagonal pyramid: the apothem, perimeter, and the height. For a sphere, all 3 dimensions are the radius. It's radius times radius times radius. For a prism, it's the length, the width, and the height. But it's only 3 dimensions. Area was 2 dimensions. Volume is 3 dimensions. If all linear dimensions, how many of them are there? 3. Are multiplied by 20, what's the effect on the area? Well, how many dimensions is area? I just said that. It's 2. So the area effect would be times 20 squared, which is 400. The volume effect would be times 20 cubed, which is 8,000. So if every linear dimension was times 20, the volume would be times 8,000. That's why if you have if you have 1 inch, sorry, not 1 inch, if you had 12 inches equals 1 foot, what is that in volume? Well, that's 12 cubed. That would be 1728 inches cubed equals 1 foot cubed. Yeah, that's right. If you know that the volume of something is like 2,500 inches cubed, you would have to do 2,500 divided by 1728. and you would get about 1.447 feet cubed. Yeah, that's how it works. If you're working with volume, you better use volume ratios. If you're working with area, you better use area ratios. A cylinder-shaped container has water that is currently 15 centimeters high. When a sphere with a diameter of 3, so the sphere, let's look at that. The radius is 1.5, so the volume is 4/3 pi 1.5 cubed. 4/3 times 1.5 cubed. 4/3 times 1.5 cubed. Well, how about that? That's just 4.5. Love it. So that is 4.5. Don't forget your pi. Okay. It's dropped into the cylinder. The water level rises to 22 centimeters. What is the radius of the cylinder container? So on the cylinder, we know that volume equals the area of the base times the height, which is pi r squared h. The only height we care about is the height from 15 to 22. That's it. It rose 7 centimeters. And we know what that volume is, right? When we dropped it in, it rose 7 centimeters, and we know that the volume of the sphere is 4.5 pi. So we know that 4.5 pi has to equal pi times r squared times that 7 centimeters. This is kind of a tricky question. So this is the displaced height. This is the displaced volume. We've never had one of those. So we actually know the displaced volume. We know the volume of the object going into the water. It's 4.5 pi. We know the displaced height. It rose 7 centimeters. We can get the radius from this. So we know it's going to be 4.5 pi. We have to divide the 7 off. That's gone. We have to divide the pi off. Those cancel out. They're gone. And then we have to take the square root. So it's going to be the square root of 4.5 over 7. And so the radius equals 3 root 14 over 14. But it says round to the nearest hundredth. So the radius would be 0.80. Nearest hundredth, you got to round correctly. Even if it's a 0, you got to put it. Love it. A frustum of a cone has a top base with an area of 200 pi. Well, we know that the area of a circle is pi r squared. So 400 pi, sorry. So 400 pi equals pi r squared. So the radius has to be 20. The bottom base has an area of 144. Well, that radius is going to be 12. You can figure that out. And a height of 72 inches. Okay. It says, what is the volume in inches? Well, let's be real clear. This was feet squared. So this radius must be in feet. Everything needs to be in inches. I know that 12 inches equals 1 foot. Don't try to do a feet squared unless you're going to square the ratio. No. So we're going to multiply our feet by 12. So 20 times 12. So the new radius, 20 times 12 would be 240 inches. The new radius, 12 times 12 would be 144 inches. All right, feeling good about that. So everything's in inches now. We want it in inches. Everything's in inches. The height's 72 inches. Okay, so every single frustum, what are the steps? I'm going to change color here. We draw our right triangle with the piece through it. I don't care about bottom or top. I just made the bottom one the bigger one. Okay, I'll do it the way they said. I don't want people to get mad. The top base is the bigger one, so you could draw your triangle upside down. Same stuff, though. So the top base is the bigger one. It's 240. The smaller one is 144, and the height is 72. Remember, this part is not actually there. So don't put any numbers there. Don't you dare put the 72 there. 72 is not the whole thing. The whole thing's not there. The frustum stops here. We draw the rest so that we can see it, but it's not there. All right, so we're going to call this part x, and we're going to do a proportion. I like to start it with x over 144. Small over small equals big the entire side over big the entire side. Now remember, you can reduce horizontally. I'm not going to do it because I don't want to confuse everyone, but you could reduce these to 3/5. You can do that. If you don't know how or when, don't. So I think fewer people understand that than don't. So I'm not going to do it, but you can, and I usually do that. But we'll go ahead and multiply. Be 240x equals 144x. 72 times 144 would equal 10,368. So 240 minus 144, so 96 pi, hex, not pi, equals 10,368. So 10,368 divided by 96 is 108. Hey, I just made these problems up. I did not know that it would work out so nicely. So this is 108. So we got everything we need. So we're going to do big cone. Remember, this is the radius of the big cone. This is the height of the big cone. So that's 1/3 pi times big radius squared. Oh, that's going to be a big number. Times big height, which would be 180. Minus the cone that's removed. 1/3 pi times little radius squared. That's also going to be a big number. Not nearly as big as the other one, though. Times little height, which is the 108. Lots of people messing this up on the quiz and test, or on the quiz. So let's see if we can make sure we get this stuff right. So really big number, 3456. That's pretty cool. With 3 zeros, pi minus 7464. 96 pi. So put it all together and we get 2709504 pi. We're rounding to the nearest thousandths. One more color change. So times pi in my calculator. Big number coming at you. The final answer is 85121 57.861. Woo! We almost couldn't have gone any bigger. It said nearest thousandths. The calculator almost ran out of numbers. Oh, what a great problem. Okay. Next one. It says y equals 1/4 x plus 3. Get these graphed. That's up 1. Oh, the region is 0 to 8. So up 1 over 4, up 1 over 5. So that's all we're drawing there. Region is 0 to 8. Y equals 3. Oh, okay. There we go. And interval 0 to 8, so there's going to be a wall over here at 8. We're already starting at 0, so we don't need a wall there. We're going to rotate it around the y-axis. So we're going to go to -8, 5. 1, 2, 3. And then down here, I like drawing the reflection. And we're going to connect reflected corners with circular motions. That's a rough one to kind of see, but there's a cone cut out of a cylinder. Let's get the numbers that we need. For the cylinder, we need the radius, that's 8. We need the height, that's 2. So that's going to be pi times 8 squared times 2. That's going to be 128 pi. For the cone, we need the same numbers, and they are the same numbers. Right? The cone's going to have the same radius, same height, because the cone does go same spots. So it is going to be 8 and 2. But this time it's 1/3. So it's 1/3 pi times 8 squared times 2. So that's going to be 128 again. That's not divisible by 3. So it's going to be 128 pi over 3. And we're going to have to subtract those. So 128 minus 128 over 3 leaves us with 256 over 3 pi. Leave exact. Done. All right. In the following figure, the volume of the cylinder is 50 pi. Okay, so we know the height's 2. Let's work on the cylinder right now. Volume of a cylinder is BH, which is pi r squared h. We know the volume. Oh, there's a pi on it. Remember that first question, there was no pi on it? This one has a pi on it. So that's 50 pi equals pi times the radius, don't know it, times the height we know is 2. So that'll be 25 equals r squared. R equals 5. If that was too fast, I divided by pi. They canceled out. I divided by 2. 50 divided by 2 is 25. Take the square root. Done. So I know the radius. What is the volume of the entire figure? All right, well, we know that this is 5 now. They told us this part's 13. We do need the height for the cone. That's a Pythagorean theorem. Hopefully you recognize it as a triple. So the cone is 1/3 pi r squared h. So that's going to be 1/3 pi times 5 squared times 12. That's going to be 25 times 4. That's going to be 100 pi. So the cylinder, they already told us, was 50 pi. We could recalculate it if you want, but we know it's 50 pi. So we know it's 100 pi the cone plus 50 pi the cylinder for 150 pi. But they said round to the nearest tenth this time. So 150 pi to the nearest tenth. 471.239. Oh man, we're done. I was having fun. Hopefully I didn't mess up anything. For Thursday, this is all I got for you. Good luck. You guys are going to do great. I'll see you on the other side.